Hi, this is John, and this is lecture 3 for week 3 of CS 1030. And so what we've been talking about this week is more interesting and complicated program constructs that you can use to write computer programs that solve more interesting and complicated problems from the real world. And this lecture segment is going to continue with that. And today is going to be, or this piece is going to be about a concept called state variables. So let's talk about what you use variables for when you write computer programs. So we've already used variables to store numbers, for example, a counter from 1 to 10 or something like that. It's also easy to store things like somebody's name or something like that in a variable. And state variables are a little bit different in the sense that state variables are special variables that you create in a program to represent to keep track of things in your program or things in the world. So let's look at an example. So let's assume that we're writing a computer program that's going to support a to-do list of things that you have or haven't done, that you need to do today. So for example, we could have a to-do list saying that we're going to need to read the notes from the class, we're going to need to practice programming Scratch, and we need to practice sleeping with our eyes open. So the question is, how do we take this kind of a real world concept, this kind of requirement for what we want the program to do, and how do we implement that in Scratch? So we'll talk about one way to do that, which would be to make a state variable for every to-do item. So we make a variable called practice Scratch, and that variable is set to 1 when that task has been done, when we've done it for the day, or it's set to 0 at the start of the day, or when whenever we first create the list. Then in the code that we write, we can check that variable. We can check if practice Scratch is 0 or 1, and then now our program knows whether we've done that task or not. Then once we do the task, then we would click a box or something in the program, and the program would change the state variable from 0 to 1, and now it would remember that the particular task we're talking about, practicing Scratch, had been done. And so the essence of the thing that we're doing here is we're using a variable in the program to remember whether something has happened in order to make our program sort of do the things that we need to do. So the state of something is the current circumstance. Have we practiced Scratch or not? Is the light switch turned on or off? You can think of a lot of different kinds of state variables, and we use them to sort of reflect in our computer program something about the world that the program needs to know. So let's look at how we can write code that examines the state and does different actions based on it. So for example, if we have a state variable called practice Scratch, and it works like we said on the previous slide, then we can write the code. If practice Scratch equals 1, then say good job for 2 seconds. Otherwise, say get to work for 2 seconds. So this is something, this is silly, right? But this is something your program might do if you wanted it to remind you to get to work if you hadn't practiced any Scratch yet today. So the way state variables work in general is we start the program with a state variable set to some sort of a default value. So generally, like at the start of the program, we haven't practiced Scratch yet. When something happens, we can change the state variable to a new value. So we can set the state variable for practicing Scratch to 1, indicating that we have. And then we can examine that value in other places in our program to see whether that's been done or not. And the state variable basically kind of serves as a kind of communication between different parts of your program, where allowing it to sort of remember something that's happened in order to sort of do the right thing. So something we can think about is what would be the state variables that we might have if we were programming something like a computer game. And so if you think about that, what would we want to represent? What would be the state of a computer game? Well, we probably want to keep track of the number of lives the player has left. We'd want to keep track of the player's position on the screen. We want to keep track of the number of enemies that are on the screen and where they are. We want to keep track of the current score. We want to keep track of maybe what level we're on, and all sorts of things like this. So these would be the state variables that would make a computer game work. If we were doing something different, like a tax program, that is to say a program which tries to compute how much taxes you owe each year, that would have state variables that indicate things like, do you have kids? Do you have dependents? What year is it? How much income have you received from various sources this year? So anyway, so the essence of the thing here again is the state variables allow the program to remember things that matter to that program. And of course, obviously then the things that the program remembers are gonna have to do with the problems that you're actually trying to solve. So I'd like to add sort of a word of caution here, which is that if you add a whole lot of state variables to your program, then writing a correct program can become really difficult, really hard to understand, because there's all these state variables and they're all gonna be sort of in different states. And it's easy for a program to get sort of confused. So let's look at an example. So if I have a state variable, state variable number 1, which represents whether a light switch is turned on or off, and I have a state variable number 2 that says whether the light bulb is burned out or not, what would it mean if those two state variables were configured in such a way that the light is on and also burned out? I mean, does that even make sense? Could that happen in a real program? Or would it be that our program would get all confused if that happens? And so one thing you can take away from this is you should sort of look for interactions between state variables that are going to cause your program to maybe get into trouble. And another thing you should think about is whether there's a different way to represent the state of the program that doesn't get your program into trouble. So another thing we could do instead of having two state variables here is have just one, and it could have a state for the light on, for the light off, and for the light burned out. So instead of 4 possible states, we'd only have 3, and all of the states would correspond in that case to states that are actually meaningful to our program. So we can eliminate potential for error in our program by using fewer state variables and making them better match the things that we actually want to happen. So it's super, super common, as I was trying to show in a previous slide, for buggy computer programs to get into confused states. That is to say, the state variables are in some collection of states where the program just sort of can't proceed. Things just don't make sense. Like maybe your game has -77 lives left, and your game just gets confused. So how do you make that less happen? Sorry, how do you make that happen less? You'd be super careful to initialize your state variables. If you don't put them into sensible values at the start of your program is sort of hosed all the way from the beginning, and it's never going to do anything that's very good. You should create as few state variables as you can get away with creating. Don't have redundant state variables storing lots of different things. Like don't have a state variable saying, am I in the kitchen, am I in the living room, or am I in the bedroom, or I'm out in the garage. Just have one state variable saying where I currently am. You have to be super, super careful to understand the relationship between different state variables. And it's often a good idea to write code looking for impossible combinations of states. So for example, the light is on and also burned out, and then just exit the program or print something like, hey, there's a problem when you detect these kind of states. And so this is, I think, really very good advice for people at your stage, but it's also exactly the same advice I would give to somebody writing computer code professionally, for example, for a car company, or for somebody who's doing research in computer science. This applies at all levels of experience, at all levels of, of capability, and it's good advice. So for assignment 3 in this class, you're going to make a Scratch adventure game, and you're going to end up with state variables similar to some of the ones that I gave examples of a little bit earlier in this lecture. And hopefully this will be sort of a fun exercise for you, and that's all for this segment. Thank you.